And then this part of the code writes to someplace outside the game address space. So it's writing to an invalid memory. I don't know why it's doing that, but I tried noping, removing that whole part out, and then there was no problem running the homebrew. So I just nope that whole part out. And that's the starting address of that code section is going to be the second address. And the third address is going to be the image space of the game do file. So we're going to open the game do file in the hex editor. And the entry point is at a fixed location in the do file, and the do file format is pretty much publicly released. So that fixed location is E0, which contains the D word 8000403C, and that's going to be our third address. And so yeah, you first write the file that's going to be injected. To the resulting file. The homebrew application. And then you write down a resulting file that has the injected data in it. And then you write down the three addresses that we just found before. And I don't quite remember the addresses, so I can't quite write it down here. But that's how this injector works. And after you execute it, you have a main do file that has the injected code in it. And all you have to do is put that resulting main do file in its original place in the game image, and then you repack it into an ISO, and then all you have to do is distribute it to forums or torrents and places like that, and people will download it, and hopefully, not hopefully, but they will accidentally have malware running on their gaming systems. So that's it for the demo. And this is and this is how the attack scenario is going to look. The scenario is pretty much the same as the Nintendo DS. A naive user brings a hacked Wii device inside a company connecting to the internal network and plays one of the games he downloaded off the web. Actually, it doesn't always have to be a USB hard drive connected to the Wii. The user could just download the game, and then he could burn it on the disk, and that would create the same effect. And that game, in fact, contains the malware. So all the attacks presented in the Nintendo DS section can be performed on the Wii, including some new ones which will be shown next. The first demo is about malware attacking remote hosts on the same network. And the Wii is assumed to be already connected to the network, and it's also connected to an external hard drive, which contains a game that the user downloaded off the web. So the attacker has a remote access tool running in the background to use after the attack has succeeded. And now we're going to launch the game to see if the malware runs. 안 돼요? Okay. Unfortunately, the wireless, too many people are accessing the wireless right now, and we can't do a live demo in this kind of environment, so we'll just have to go with the video. So yeah, that's the game list screen, and the user is running the game now, which is Mario. And what the malware does is it attacks hosts on the network using known vulnerabilities or 0 days and installs a backdoor on the compromised host. So like after the game starts, a new user is shown on the ProAct console. And you can do lots of things on the target computer, like taking screenshots and accessing file system and all that stuff the backdoors can do. So that's it for the first demo. And the second demo is the malware bringing down the network by accessing the router with a weak or default password. And the Wii should be connected to an internal network, which we see, and we see that the internet is accessible. And we have ping running in the background to check the network's condition. The router IP shows 9.49.9.2 right there on the right. And we're about to run the game now. The malware in this one uses a default password to access the router and kind of plays around with the settings in the router. And the game is loading up. Taking a while. Okay, the game is playing, and ping is starting to fail, and Google is not accessible anymore. Skip this part. And the router IP is changed to a bogus IP, including the DNS and the gateway address. And that's it for the second demo. And the third demo is kind of long, but we're gonna kind of skip a lot through it because we don't have enough time. And it's the third demo is to show a malware redirecting the user's request to the attacker server using DNS farming. So the attacker created a fake DEFCON page to collect the ID and password. And to make the users access the fake page, we run a custom DNS server and monitor the ID and pass info with tail. And we're running a botnet IRC server in the background. So we're pinging DEFCON now. Which shows the IP address of 173.14. Whatever. And now we're going to run the infected game. And the game is running. And the Google and DEFCON sites show the IP at the same IP as the DNS server. So you can see that the user's requests to both pages are being redirected. And the fake page logs the ID and password to the attacker's server, which is shown on the screen right now. And when the user accesses Google, then Google loads a malicious page. This page is also created by the attacker, and the malicious page in turn downloads a backdoor, actually a botnet client. And in just a second, the the client should join, the zombie should join the botnet server, which you can see on the screen right now. So these are the kinds of things you can do with malware injected in console games. Okay. And this concludes the section on gaming consoles. And next, I wanted to talk a little bit more about malware on smartphones, but due to the time constraints, I guess I'll have to kind of fly through the slides. What I want to demonstrate is that the same malware injection techniques presented in the previous slides can also be implemented in smartphone applications. So we'll first start with iPhone. And basically an iPhone application package is a zip file, and after unpacking it, you can find the main executable inside, which is a Mac O binary. And since malware injection techniques for Mac OS X existed for several years, and all iPhone and Mac executables are in Mac O format, all the malware techniques for Mac can be used for iPhone binaries. The only difference is that after the injection is done, the binary has to be signed and repackaged into an IPA file, and finally added to the Hercules database so the general users can download it. And I was supposed to show a little demo for a proof of concept, but since time is short, we'll have to skip that. And the same thing can be done with Android applications. There's already various tools out there that can modify the APK files and recover the Java source code, and other tools that can modify the binary in intermediate code level. And with these tools, the attacker can add custom code into the existing application, either in source code or intermediate code level. So the same things can be same malware techniques, injection techniques can be performed on smartphones. And that's all for the attacking part. And the defenses.